Hello everyone. Today we are going to solve a problem based on Reim's theorem that we learned in the previous video. If you are not sure of Reim's theorem, please check out our previous video based on that. Get your ideas and concepts cleared so that we will directly plunge into solving this problem. Let's get started. Suppose you have a quadrilateral ABCD such that the sides AD and BC intersect at a point E. The quadrilateral is given to be cyclic. That means there exists a circle passing through the 4 points of the quadrilateral. Now let us consider the circle through the vertices A, C and E. So it will be like this and call the center of the circle by O. Then we have to prove that BD is perpendicular to OE. So we have to prove BD is perpendicular to OE. Let us use Reim's theorem to prove it. First of all, consider the two circles displayed in red and green as the circles in the Reim's theorem. Now what does Reim's theorem say? When you consider three collinear points, two pairs of three collinear points through the points of intersection of those two circles, then the formed line segments in each circle are parallel. So consider the three collinear points to be A, D and E. The first one, where you could see that A is the point of intersection of those two circles, one of the 2 points of intersection, and similarly BCE as the other pair of collinear points. Over here, C is the other point of intersection of the two circles. BD is the chord formed by the 2 pair of 3 collinear points in the green circle, and these 2 collinear points intersect the red circle at E. So we get EE. But what is called E? Well, it is the tangent at point E. So if you are not convinced, you can convince yourself by a limiting argument. Try bringing the second pair of collinear points, the line formed by them, as you approach the point E, and you will see that the chord formed in the red circle will approach the tangent at point E. Therefore, the tangent at point E will be parallel to BD. This is our first observation. And now it is immediate, because when I extend BD, I know that OE is already perpendicular to the tangent at E. That's the definition. That's like a trivial property of tangent at a point. So when I extend OE, it will of course be parallel to BD, because BD itself is parallel to the tangent at E. So by just observing this simple configuration using Reim's theorem, you can derive some amazing properties that are not trivial. So I hope you understood how we exploited the property of Reim's theorem. This can also be proved here, but I have done a great exposition in different forms of Reim's theorem. You can watch our previous video to get a clear picture of Reim's theorem. Thank you for watching everyone. Bye.